Let's talk about finding the coefficient mu. Let's see. Does everyone remember the formula for friction? So friction kinetic is equal to mu kinetic times what? The normal force. And if we need the normal force, which it looks to me like we do, it means that we have to do Newton's second law in the y direction. Okay? Are you ready to do it? Yeah? All right, so Newton's second law in the y direction. Sum of the forces in the y direction equals mass times acceleration in the y direction. I don't think I have to redo my free body diagram. I think this one's good enough. Anybody unhappy with that one? We happy with that? So I'm just going to stick with it. My question to you guys is there acceleration in the y direction? Yes or no? I see some people shaking their head no. Is there acceleration in the y direction? There isn't in my coordinate system. There is not in my coordinate system. In my coordinate system, I have defined y to be going perpendicular to the ramp. And so even though you look here and say, well, there's acceleration in the y direction for the skier, from the person standing off the hill looking at them, I am being the coordinate god and I reject your system. And in my system, y is perpendicular to the ramp because that makes my life easy. And if I do that, and we haven't said that the skier is airborne and going over bumps down the ramp, then this skier is always in contact with the ramp. That makes their motion in the y direction constant. And acceleration 0 in the y direction. Does everyone agree with that? Okay, yeah, that's why I change my coordinate system. And so here's the cool thing about this. This is 0, which makes my life easier. How many forces do I have in the y direction? Well, I'll go back up here and look at my free body diagram. I've defined the normal force as positive, so I've got normal force, and I need the y component of weight, so mgy component, and that's going to be equal to 0. And I know that the mgy component is the cosine. Remember, we decomposed the vector up here. These we have just memorized. Okay, so if you come back down here, then I can substitute in the y component, which is mg cosine theta, and that's equal to 0. And so the normal force is equal to 600 newtons times the cosine of 25. And that is 543.78 newtons. Everyone agree with that? Do please double check my math. Sometimes when I'm up here, I make a mistake. Everyone's okay with that math? Okay, good, good, good. All right, so now I have the normal force. I do know the force of friction. I didn't even have to calculate it. That was given to us up here. And so I can just rearrange the friction formula for a mu kinetic and solve for it. Okay, so if I want to rearrange the formula, it's mu kinetic equals the force of friction kinetic divided by the normal force. That's just this formula rearranged. And that's 45 newtons divided by 543.73 newtons. It's going to be unitless, so newtons are going to cancel. Now, before I do this, it's snow. Do we expect a lot of friction or a little friction? A little friction. And I just want to remind you that the mu has to be greater than 0, but less than or equal to 1. 1 being a lot of friction and 0 being frictionless. So if we don't fall in that range, we have made a mistake. Okay? All right, so I'm lazy. I'm just going to do 1 over that instead of divide by it and multiply by 45. And I get a mu of 0.827. Do you guys agree? Oh, I did say, what did I say? Oh, 0.0827. Very small though, right? Very, very small. All right. I'll probably do 8.3. I'll round up to 8.3. All right, so 0.83. Good Lord. Are we happy? Okay.